So students, today what I'm going to do is I want to talk about some practicals of class 12 and some procedures of that, and the theory part that will be coming for your upcoming practical examination. So that I will be talking about right now. Okay. So the first practical is Ohm's law, that is verification of Ohm's law, and for that practical, you have already done it in your theory part, so I'm just discussing it. So first the practical is verification of Ohm's law. Okay. So as per Ohm's law, you know that suppose you have a resistance over here, and if you apply a potential difference through this resistance, across this resistance. So if we increase the potential difference, the current through the resistance will be increasing. So for this practical of verification of Ohm's law, what we need to keep track of this voltage, that is a potential difference between these 2 points. And the second thing is, we need to just measure the potential difference and also the current flow through the resistance. So we need an ammeter. So we need an ammeter in series with the resistance, obviously, so that when I am applying a potential difference to this resistance, the current will be flowing through this, and we can easily measure the potential difference. So suppose this is a voltmeter. Suppose this is a voltmeter, and this is an ammeter. So what we can do is, we will be applying a potential difference here. Now just consider this is a cell or a battery, whatever you wish. We can keep a switch over here so that we can just turn on the circuit or turn it off as our wish. So I'm just keeping a switch over here, and this is the setup. So we have to measure the potential difference across those. Okay. Now, for this verification, that means we need to check that whether the circuit is following that V equals to IR relationship. So that is, if you vary this potential difference V, we need to check how this current is varying. There must be increasing, and as we increase V, this I must be increasing. So we need to check that. So to check that, we need a system such that we can just vary this potential difference. Okay. So we need to do something in this circuit so that we can just vary this potential difference. So what we can do is, we can connect here a rheostat, that is a variable resistance in short. Okay, I am just changing it here like this. Suppose here I am taking a rheostat over here like this, and it has a pointer over here. So actually what we can do is, we can move the pointer over here. Okay. So okay, and so here is a rheostat, and I am connecting another resistance in series of this rheostat, okay, like this. So this is a resistance, but we don't need to know the value of this. Just a high resistance, we can just consider, okay, of like 20 kilo ohms, we can just consider it, okay. So this is a high resistance. So now here we have a circuit, we have a EMF or a cell over here that is actually giving us some EMF, and suppose if you just turn on the circuit, so there will be a current flow through this circuit, okay, and so there will be a potential drop across this resistance. Now if you move this pointer from here to here, then actually I'll get a more potential drop. Why? Because the potential is actually of a finite amount that is dropping over here. due to the current flow through this circuit. Okay, such a current is flowing through this circuit, and we are getting a potential drop of a finite amount. Suppose it is I'm just considering like 4 volts over here. Okay, so we are getting a potential difference of here and here. Okay, not here, sorry. I mean here and here will be 4 volts. Suppose across this resistance. Okay, I mean so if we just connect this pointer over here, so I mean due to this part of the resistance, the potential difference here, I mean the potential difference here and here is a bit less. I am considering it's like, okay, it's 1 volt over here. So as we move the pointer towards this direction, so the potential drop eventually increases because due to this resistance. So as we go from here to here, the potential drop increases. So if we just drag the pointer over here, I'll get a higher potential drop. So here we have got a circuit so that we can vary our potential difference. Again, I am writing the equation V equals to IR so that we can vary our potential difference. Okay. Now here is the circuit. So from here, and by moving this pointer, we can vary the potential difference. And as you vary the potential difference, the current through this path, see here the current is flowing. There is a potential difference between these 2 points, and the current will be going through here. So as you vary the potential difference, the current through this path will also vary. Okay, and to measure the voltage or potential difference across this resistance, we have a voltmeter here. Like, if I wish, I can also connect the voltmeter like this here. I mean, this is more appropriate. Why? Because in this case, I am just measuring the potential difference across this resistance on me. Okay, excluding the ammeter. So ammeter is not readable. So here we are getting a potential difference V across the resistance, and we can measure the current through the resistance by this ammeter. So we can easily take some values of different potential difference, and for that each potential difference I can note the value of the current. Okay. So if I do that, then I'll get an idea of this resistance. So actually, how do we verify the Ohm's law? Actually, what we do is we will move this pointer from here to here. We will note some different values of potential difference, like 1 volt, 2 volt, 3 volt, 4 volt, like this. And for each value of potential difference, we will get a corresponding current flow. I am just considering like it could be 1 ampere, 0.1 ampere over here, and here to be 0.2 ampere, for this case 0.3 ampere, here 0.4 ampere, like this. So all this data I will be just copying, and using this data we'll just draw a plot. Okay, and the plot is like this. That is, we are plotting I proportional to V, I versus V. And as we vary the potential difference, the current will be increasing like this. It's a straight line, obviously. As you know that in case of Ohm's law, this equation V equals to IR is actually the equation of a straight line that passes through the center. You know that in mathematics. So from here, the graph should be like this. Okay, this might be a straight line passing through the center. If the graph is not like this, then there may be some instrumental error. Maybe you are applying high potential difference over here so that the wire is heating up, or there is any other issues. Maybe some wire is loose enough. So like this, we will get a straight line. We must get a straight line, and if you just measure the slope, that is, this part is delta I, the change in current and change in voltage. If you just draw a triangle to measure the slope. Okay, so this part is delta I and this part is delta V. That is change in potential difference. Okay. Now for any arbitrary triangle that we will draw on the graph paper while doing the practical, So from here, we will get delta V and delta I. So if we just divide delta V and delta I, we will get the resistance. Okay. So if we are asked to find the resistance over here, if we are asked to do so, but if we are only told about to verify the Ohm's law, so this is a straight line. That means here I is proportional to V and is actually maintaining this equation. So the graph ultimately tells us that Ohm's law is valid for that particular practical. Okay. So I think it is clear to you that how to proceed. What is the theory behind this? And see, for the upcoming practical exam, in the chapter where you have Ohm's law, the theory part is sufficient for your upcoming practical exam because we are not able to do the practical in our own hand, in your own hand in the lab. So we need to give theoretical questions related to the practicals. So there you just only need that theoretical concepts of Ohm's law and nothing else. Okay, so that's it.